Next, we go to Coulomb's law. This is very important. Let's say we have two charges, okay? Two charges renamed as Q1 and Q2. The force between 2-point charge Q1 and Q2 is directly proportional to the magnitude of the charge and inversely proportional to the square distance between them. That means if the charge has a strong magnitude, so the force of attraction or repulsion between 2-point charge is proportional to the magnitude. And if the location between two charges is increased, so the force of attraction between 2-point charges will decrease. Alright, refer to these equations, we can see here that the force is proportional with Q1 multiplied by Q2 divided by R12 squared. Or we can relate with a constant K, where K is equal to 1 over 4 pi epsilon naught. That is a constant in free space. So from this equation, we can see that the force increase when the magnitude of Q1 and Q2 increase. And it is inversely proportional with the square of distance. So that means if the location of Q1 and Q2 is far away, so the force between Q1 and Q2 will reduce. Let's say the force at position Q2, F2 is equal to KQ1 Q2 divided by R12 AR12. So AR12 represent a unit vector acting on Q2. The unit is Newton. So the K here is equal to 1 over 4 pi epsilon naught, where epsilon naught is basically a permittivity of free space. The permittivity is related with a electric field. So if we have two charge, so the force experienced by both charge will always be the same force, but the direction will be opposite each other. For example, if we have Q1 and Q2, okay, if Q1 and Q2 have a same charge or the same sign, if both positive, it will repel. If both negative also, it can repel. But if both charge has different sign, so it will attract each other. So we can see here, the first one is in these directions, because the first one is basically from this charge. So it's acting like this. And then we have F2 in this direction, because the F2 is based on the Q1. But the F1 and F2, it can be whether positive or negative. Okay, depend on the sign of Q. So we will see later on. The force in Coulomb's law. Force is mutual. The two charges experience the same force but in opposite directions. Like I mentioned earlier, Coulomb's law is linear. If charge n times larger, the force n times larger too. Alright, the properties is linear. And then the force on a charge is the summations of all force acting on it. Let's say you have more than 2 charges exist in the system. So if I want to find what is the total force experienced by one of the charges, so we have to find the total force acting on the charge by the all charges exist in the system. Okay. Now from the definition of force, this is more important thing. We want to find the definition of electric field intensity. How can we find the electric field intensity by force? Let's say the force at Qt is Ft. The force at Qt over the total charge of Qt is equal to Ft divided by Qt. This is the intensity of electric charge at position Qt. So let's say we want to find what is the intensity of E field in this point. So we have to divide the force acting on Qt divided by the magnitude of Qt. So we can define the ET or the electric field intensity at point T or charge T is equal to Ft divided by Qt equal to Q1 divided by 4 pi epsilon naught R1T square in the direction of the unit vector is R1T and the unit is Newton per Coulomb or volt per meter, the same unit. Normally we use volt per meter. So let's say you have a positive charge Q1 here, so the direction of E field is going out. So the ET is going out like this. So this is the distance between Q1 and Q2. Normally the R12 is a vector. Okay. This is a unit vector. So the unit vector is basically the vector R12 divided by its magnitude. Next, electric field intensity due to the point charge. This is a general definition. E is equal to Q divided by 4 pi epsilon naught R2 square. And it has a unit vector AR, volt per meter. Okay, let's say we want to find what is the E field here, or electric field intensity at this point. So this is the formula. This is the total E field if we have more than 2 charge. Let's say, okay, we want to find what is the E field at point P. So we have to calculate the total electric field contributed by the individual charges exist in the system. For example, I have Q1, Q2, Q3, Qn. So the Q1 will provide E1, Q2 will provide E2, Q3 will provide E3, and Qn En. So it has to be adding together. And this is how we write the total E field at point P. The E total is equal to E1 plus E2 plus E3 plus so many E, and this is how we write. And it's equal to Q1 divided by 4 pi epsilon naught R1 to R1, and then Q2 divided by 4 pi epsilon naught R2 square AR2, and so on. This is for point charge.